All right, so here's a recording for the Unit C, specifically for doing a difference in proportions. So here's the completed example. If you're doing a difference in proportions. So what you would first need is to decide what are going to be your two groups. I did male versus female, and then my target population was college students. And then the variable was them bringing a beverage to class. So just as an instructor, I noticed some students have water bottles, some have coffee, some have different things, and they usually have it frequently. And then there's some students who don't bring anything. So that was my comparison between the two groups, either having a beverage or not. Now, the data that I collected was just observational. It was just me from students that I saw in the classroom. But I do mention this, just it was just a convenient sampling and the data. So because it's just a convenient sampling as opposed to like a random sample, we can't use it to generalize to the larger population of all college students. Again, also the sample sizes, they don't need to be very large for this project. I did 6 male, 13 female. It's okay if the number isn't exactly the same, but I think a good number to aim for would be maybe like 10 and 10. But if you're a little bit under, a little bit over, that's going to be fine. But again, shoot for at least 10 and 10. I was able to get 6 and 13. And again, this is just for demonstration. Then once you are ready, you're going to do your observation, right? So for me, it was that out of 6 male, 3 had a beverage in class, and out of 13 females, 9 of them. So already it looks like maybe female. Female is going to be the larger proportion. So what I'm going to do here now is show the stat key part. So you would go over to stat key and actually go very, very beginning. And for this one, if you're doing two different proportions, this is going to be two categorical variables. And so we've got drink or no drink, and then we've also got male and female. So those are the two different variables. Now, what you'll need to do is edit the data with what you collected. And I'm going to zoom in here. And so it's already got a pretty nice, like just something to fill in here. The only thing is we don't have a third category here. It's just either they have a drink or they don't have a drink. Now this you can change to male. Right now it's male and female, which is what I'm using, male and female, but you could do whatever two groups that you do, group A, group B, children, adults, younger, older. You'll decide who are going to be your two groups. But to make it more the context of what I'm doing one group beverage, or you could put like yes or no, but I'm going to put those that had a beverage, those that had no beverage. So that's kind of like my yes and no. And then I'm the spaces here, as long as you don't get rid of the commas, but spaces won't hurt anything. So what I'm doing is I'm just hitting some spaces to make things look a little nicer, and that there's a column for male and there's a column for female. But these numbers I do need to change. The only thing is remember there was 6 total. If I zoom in here on the male, that was 6 total males, and 3 I said had a drink, which means 3 did not have a beverage. So it's going to be that 3 had a beverage and 3 did not have a beverage. So that's how we enter that. So you're not putting in the total 6, you're splitting them up versus like yes and no. And then for the female, there was a total of 13, but 9 had a beverage, which do the subtraction means 4 did not have a beverage. So that's what you're doing, is just a bit of subtraction of the females. 9 had a drink or a beverage, and then those 4 left that did not. And what you may want to do, oh, maybe you don't need to, but maybe just copy and paste this just in case you ever need to reuse it again. But the top up here is considered like a header, and it's already checked that the data has a header row. But as long as you just change your information and hit OK, you'll see that it generates this side-by-side box plot. But more importantly, it's got over here the frequency table. And what you're going to want to do since I put my male and female as my columns, those are my two different groups. And so I want to click on the column to see the proportions. And so right here, I'm also not really concerned about like the no beverage. I'm really doing a comparison between how many had beverage. So 50% of males had a beverage, and 692, or about 69.2%, had a beverage for the female. And so this is what I want to take an image, like take a screenshot of this image and add it to my project. So again, here's just the way that I entered in the information. And then here is the table. And I've already done like a screenshot and copy and pasted it. And then you can size it over here. But as long as you get this in here and it's legible, that's really it. And then make some comments. Again, the comment is that it looks currently right now like female, that more female bring beverages to class. And so I just made a note here. Just space this up. Based on the observed samples, it looks like a larger proportion of female bring a beverage to class. And so you just want to make a note of this. This was for the female, 692, and the male was 05. And so I'm going to keep that in mind, since female seems to be the higher proportion. If I do any subtracting, I'm going to put them as my group 1 and my male as my group 2. So that will take care of part 3. Now, part 4 is doing a confidence interval. So you're going to use the same information, except in StatKey, go back to the beginning and go here, difference in proportions. So we got male and female group, and you're going to have to do the edit data again. But this time it looks a little different. It's doing the numerator and denominator for the first group and the second group. And so again, this is what I'm saying, since I know from the last step that females seem to be the larger proportion, they were 9 out of 13. And for the male, it was 3 out of 6. So this time when you are putting the data, you're putting the total for each group and then how many cases in each had the beverage, or whatever you're doing for your yes and your no. So 9 out of 13 and 3 out of 16. And remember earlier when I had my data, I had the male as the listed first, but now I'm just doing it the other way. I'm doing female as group 1, male as the second group, just because they're a smaller proportion. But these are decisions that you'll make as you are doing your data. But now once you've got it in there, hit OK, and it will already come up here and do your group 1, for me happens to be female, minus the male group. And here's the difference, 0.192. So right now, again, it seems like female might be the higher group, but we're coming here to get a confidence interval. So you'll generate 1,000, and then you'll hit your two-tail. And down at the bottom, it's bootstrapped, and it's giving you this interval, negative 295 up to a upper bound of 679. And so every time you do this, again, you only need to do it once, but again, since it's randomly choosing, it could change. So, but I'm going to go ahead and record this, negative 295. And notice that I've done this project already before, and so my numbers are going to look different. So negative 295, actually, that's pretty good. And then 679. Oh, actually, they didn't really change. This is cool. So there's the negative, there's the positive, and then you want to make a comment because 0 is contained in there. The confidence interval is giving us more the impression that there might not be a difference in the proportion. Again, it's college students bringing a beverage to class. So that's it. That'll be your confidence interval. And then the last part is doing the hypothesis test. Now, again, because of an earlier observation was that the female seemed to be the higher proportion, my test is going to be, is there a higher proportion of female that bring a beverage to class than male? And so it would be, here's my HO. Maybe the proportions are the same. Maybe the proportion for female is higher. You can do a less than test if you want for your study. It's just all going to depend on what data you collect and which way you see it being best stated. You can also do a difference, so like a two-tail, but if you do a two-tail, make sure to multiply by 2. But I'm just doing a right tail with proportion being female higher. Now, you'll need to go back to the homepage of StatKey, and you'll need to move over just one more to right here, test for difference in proportions. And it's going to be similar. You're going to do your edit data up at the top. And again, I'm going to keep the female 9 out of 13 as group 1 and the male 3 out of 6 as the second group. And there's the same exact statistic, the 0.192. And that's what I'm going to put a little lasso around, because that's what's going to go down to get our p-value. We're going to generate. Now, again, you can do left tail if you need to. You can do right tail, or you can do two-tailed. Me, I'm choosing to do right tail. And this is not the p-value. We got to make sure that we go and take our difference, our subtraction, 0.192, and that we put it way down here at the bottom, 0.192, and hit OK. And then right above it is the p-value, 0.375. Again, I haven't been doing it, but this is what you would take a screenshot of. I'm just taking a picture of this. So I just took a picture of that, just so that I can add that over to my project. But it's 375 is the p-value. So I'm going to go make a note about this. So notice I did this before and I got 374, but it's 375. It's going to highlight that. And then notice the things that are here. There's the statistic when we subtracted the sample 1 for the sample female minus the sample for the male. And because it's a large p-value, and I mentioned over here, do not reject the null hypothesis at 5%. There's not enough evidence that a higher proportion of female bring a beverage to class. So make your generic conclusion and your conclusion in context. And then all I'm going to do come down here is just, I'm going to update this real fast just because I changed the picture. But this is the picture that I just took. Should be this one. Yeah. So you would just drop in your picture here. And the main thing is right there, you want to make sure that you take that step to put your statistic down here, whatever your difference of proportions is, to get your p-value, and then make your conclusions. Oh, I took a picture of my face right here. I need to get rid of that. But anyhow, that's the entire project there from start to finish. I hope that helps, but let me know if you run into questions.